All right. So hello again. And my name is Erica, and I am one of the children's librarians here at the Berkeley Public Library. Thank you all so much for joining us today. I just wanted to say a few things before we get started. First, the Berkeley Public Library acknowledges that we sit on the unceded traditional lands of the Ohlone peoples. We honor with gratitude the land itself, as well as the Ohlone peoples who still live, work, and play in this region. The Berkeley Public Library condemns all forms of hatred, racism, and other forms of discrimination. We are outraged and saddened at the violence and racism towards Asian American, and African American communities. We stand in solidarity with all marginalized people that have been subjected to hatred and intolerance, and we celebrate the differences that contribute to the strength of our community. Everyone is welcome here at the Berkeley Public Library. I just want to remind you also that there are portions of this program that are being recorded. So we are being recorded right now so that we can put them up on YouTube for later viewing. Because of that, we'll ask you to stay muted for your privacy. But after Karen tells us about the activity, so we're going to all do an activity together, we'll pause the recording and you'll be able to unmute and show your creations that we'll make. But in the meantime, please stay muted and you can ask questions or make comments in the chat. And also make sure that you have either some spaghetti or some toothpicks and some gummy bears, which you can eat later on, or marshmallows, or you can even use pencils and Play-Doh. You can, use your imagination, but we're going to be building something with this. So this is for later. I also wanted to tell you that the amazing storytelling group Ethnotech will be doing a virtual program with us on Thursday afternoon, May 20th at 3:30 p.m. And they'll be telling stories from all around Asia. And also, have you heard of the peregrine falcons that hatched at the UC Berkeley Campanile? Well, we'll have someone to talk about those and other raptors in a virtual program on Saturday, May 22nd at 2:30 p.m. And these programs are all sponsored by the Friends of the Berkeley Public Library. And now, the main event, we have engineer Karen Wang from the American Society of Civil Engineers here to talk to us about her journey to engineering and to lead us in that activity. And I'm going to unspotlight myself and let Karen take the stage.
Hi, everyone. Like Eric said, my name is Karen Wang. I am a civil engineer. I am really happy and excited to give this presentation to everyone and tell you a little more about engineering and also my experience as a woman in engineering. So let's go ahead and get started. I will share my screen now. Can everyone see my screen? Okay, great. So life as a civil engineer. I'll give you a little bit of background about myself. I moved out to the Bay Area in 2015 to get my master's in structural engineering at UC Berkeley. And after I graduated, I stuck around and I've been a structural engineer for the last few years, got my professional civil engineering license in 2018 and have been practicing structural engineering since then. However, recently I have switched into the construction side, and so that'll be a little bit of a different experience for me. So, life as a civil engineer. This is a picture of me at one of the job sites of one of the projects that I've worked on. So it's also always really cool because most of the time as a structural engineer, I spent most of my time in the office, doing calculations, designing different structures, but once in a while, I have the chance to go outside and see the structure that I have designed, constructed, and like in real life, very large. And it's a really cool experience to see, to see what you've designed actually get built. So, what is engineering? Does anyone want to type in what they think, what engineering in general is? Well, engineering is basically using math and science concepts to create new things and solve problems and basically make people's lives easier. So as you can see on this slide, there are a couple different things that people use in their everyday lives that were made possible because of engineers. So one of the first things that I think everyone uses every day is a phone. Before phones were invented, it was really difficult for people to communicate with each other like in real time. If you wanted to talk to someone that lived in New York, you would have to write a letter or travel all the way over there to see them to be able to talk. Cars, before cars were invented, people rode horses, they walked, they rode bicycles, but those were all much slower than the speed of cars. And since cars were originally invented back in the early 1900s, they have been improved in many different ways because of engineers. Cars go much faster these days, and a lot of them are electric and are much better for the environment. Prosthetics help people who are disabled and have lost a limb previously to be able to function and do the everyday activities that they were previously able to. Buildings are really important, I think, in everyone's lives. They keep people sheltered. These high rises provide great views of the city. And importantly, in the Bay Area in California, where there's earthquakes, we need engineers to design these buildings to help stand up in an earthquake and keep everyone safe. And lastly, on the slide, I have rocket ships, which were engineered a few decades ago and have enabled humans to travel out of the Earth and onto other planets, or onto the moon, sorry. Onto planets, hopefully sometime in the near future. We'll see.
Oh, and Karen, sorry to interrupt you, but I just wanted to let you know that in the chat, you got a couple of answers to your what is engineering question here. We said, Sequoia says building a creation, and Morgan says when you're building or creating something. So you've got a couple of answers there from the chat.
Yeah, those all sound great. I'm trying to see where my chat is. Do you know? Oh, I see it now.
Yeah, it's at the bottom.
Okay, there we go. Okay, I'll keep this on the side so I can keep an eye out on what people say. So what is civil engineering? Civil engineering is a little more specific. It essentially is anything that has to do with a city. So here's like a picture of San Francisco. And if I click through, you can help me identify the different aspects of a city that civil engineers made possible. So can anyone identify what I've pointed at with this arrow here? Anyone? So this is one of those buildings that I was talking about downtown. It's most likely an office building where there are lots of different companies that work out of here. So this building has to be engineered to, yes, skyscraper. This building has to be engineered to, like I said, withstand wind and earthquake forces, as well as be able to stand up with all the people, furniture, all that kind of stuff in there. So next up, we have this structure here. Does anyone know what that is? So this is the Bay Bridge, and it enables people from East Bay to travel all the way across the bridge to the city. So these bridges have to be able to support cars, the movement from the cars, also wind and earthquake. They're really important to get people from place to place. Next we have over here, and also here, I don't know if you can see, but these are roads which are also designed by civil engineers. So we'll go through in the next couple of slides and talk a little more in depth about these structures. So roads, these, I'm pretty sure everyone sees these every day. You'll see it when you go outside your house, in the city, when you're going to the store, going to schools. And so the kinds of things that are on roads include cars, people, bicycles, big trucks, people just walking. So these are all very important. These are all important for the roads to be able to support. So engineers have to design roads that are wide enough, that go to the right places, and then they also have to engineer these traffic signals here to make sure that, like at an intersection like this, cars don't run into each other. So that's really important. And then, as you can see from this photo, those lane markings that are on the ground are also really important because they clarify, you know, what kinds of things can go on which side of the road, like bike lanes. You can see in this photo, we have these lines. Does anyone know what the difference in a solid line versus a dashed line is? So generally when you're on the road, a dashed line, and it's a single lane road, a dashed line between these two lanes, this on the right lane, that's traffic going in one direction, and on the left-hand side, traffic is going in the other direction. So if you see a dashed lane, that means if you're stuck behind a very slow truck or a slow car, you are able to go into the other lane to pass the truck in front of you. However, if there is a solid line, that means you're not allowed to. And so these were decided on because of engineers who realized that, like, on some parts of the road, some parts of the road, visibility isn't that great. You can't see 200 feet in front of you that a car is oncoming and could potentially hit you. So it's important when you're driving to pay attention to these road markings. So next we have bridges. This one, I hope everyone knows, is the Golden Gate Bridge. And that helps people travel from the city and into all the area, the North Bay, I guess, Marin, Mount Tamalpais, all the really nice spots up there. This one I think is in Ireland. I need to double check. We have another bridge here called the Millennium Bridge, which is in London. This one is really cool because this is a pedestrian walkway. So people use this to cross this little channel. But this channel also is where ships will travel up and down. So when there's a ship that needs to go through, this whole bridge rotates up so that a ship can travel underneath. And this last one here is DuSable Bridge in Chicago, and it's kind of the same idea. When the bridge is lifted down, cars and people can go across this river, and then occasionally when there's a big ship that's passing through, they'll need to be, the two sides of the bridge will lift and then allow the ship to pass. So another thing that you won't necessarily think about is water. Water is really important, and that's another aspect of civil engineering that is really important to have a functioning city. So when you brush your teeth, when you flush the toilet, those all require an engineer to design the different pipes and the different ways that they can get water from, like, a big water treatment plant into your house, and make sure that the water that you get into your house is clean so that when you use it, you drink it from the sink, you don't get sick. And last, I have buildings. Like I said, buildings are probably the most common thing you'll think of when you think of civil engineering. So on the left side here, we have skyscrapers. In the city, some of these will probably be office buildings, others will be high-rise apartment buildings. And these are important because in some cities, you just don't have a lot of land to build lots of different little houses. So instead, people build vertically so that they can fit more people on just like a small plot of land. Here on the right, we have just a normal single family house. This is probably a little more what you're familiar with if you live in the East Bay. And then down here, we also have another apartment building, not quite as tall as these, but out here, we have a little bit more land, so we don't need to build as tall as the ones in San Francisco. So, that is my brief overview of engineering and civil engineering in general. Like Erica said, our next activity is going to be building spaghetti towers, but if you don't have spaghetti, don't worry, you can use pretty much any different material that you can find in your house. I have some noodles here that I'll be using, some spaghetti, any kind of noodles. And then so we're gonna be calling these members, and then for the joints, you can either use marshmallows, gummy bears, Play-Doh, tape, anything that's kind of sticky, and then we'll hold all of these members together. So before we start, I'm going to give you a brief overview of what we're trying to do. So today we're going to try to build the tallest tower that can stand up on its own. So this is kind of going to simulate designing a building in real life that structural engineers will have to do. So in real life, the kinds of things that engineers have to design for are the weight of people, furniture, anything that you put in your house. And then occasionally, like if you have a big windstorm or if you have an earthquake, you also have to design for lateral forces, which will shake and blow on the side of your building and just move it from side to side. So today we're not going to think about that part as much. If you do want to challenge yourself, you can try to build a building that can withstand, like if you blow on it or if you shake the table a little, see if your structure can stand up even after all of those movements. So I will also going to show you, I've built a couple little things so far. So before you start, I wanted to kind of give you some tips on how to make your building stand up. So I started with a triangle. So this is probably the most basic shape that you can make. Triangle has 3 sides and then 3 members and 3 joints. And I've also built a square, which you can see here. 4 members and 4 joints. You can also build 5-sided shapes, 6-sided, whatever you feel like today. But I want to point out the differences between the shapes. So here, if you look at this triangle, you can test this out and build this yourself, but triangles are pretty strong. If I put some force at the top and try to move it around, it's pretty rigid. However, if I do the same with my square, you can see that it's a little wobbly. It likes to move around a little because these joints aren't super stiff. So one way you can help the structure not move around is by creating basically triangles within the shape. So if I take another little member and stick it in between here, these corners, you can see that the structure is a lot stiffer now because I have 2 triangles now. Another thing that could help it even more, because it still moves around a little bit, not nearly as much, but maybe if I add another member across this side, this will help a little. So yeah, this one's pretty stiff. It doesn't really want to move. So just keep that in mind when you're building your structures. Triangles are your friend, and they'll help your building not move around, which will help you make your towers taller without them falling over. So that's the end of my presentation. We can go ahead and get started on the activity now.
Okay, and I just want to mention to all of our attendees that this is the end of the recorded part of the program. Those of us who are live here will continue. We're going to go ahead and build our structures, and then we'll put this video up on YouTube for everyone to watch later. So we'll say goodbye to our YouTube viewers, and take care, everyone.